one is. The second one is, but the first one is not. The first one is not a function. Check your X on number 1. The first one is not a function, but the second one is a function. Okay, you got a question? Okay. So yeah, you would think that the second one, hey DJ, I love when you call roll. Hey DJ. So yeah, the first isn't because the 4 repeats with a different Y. Hey Triple Pound. We're going to talk about functions today. So I'm going to just do a clean little pre-algebra functions. But yeah, so be careful because check your 4. So remember, for every input, we can only have one output, right? So here I have a number 4 as my input, but for the output, it's going to 6 and 8, and that can't happen. The 4 cannot share with anybody, okay? So we cannot have a double output for this input. It can only be 1 and 1. It can only be 1 and 1. So whenever you come to this second one right here, even though I have 2 and 9, just understand this is the same number. It's only going to the number 9, and 3 is only going to the number 2. This would be the same point if I was to put it on a graph. Then it would be exactly the same point. So you have to think about it like that. If I was to graph this relation, so a set of ordered pairs is going to be a relation, okay? So if I was to graph this on a coordinate plane, I need to see if my X is going to repeat. So here I have 2, 3, 4, 6, then I have 3, 5, remember? It doesn't matter what order it's in. So 2, 3, then I have 4, 6, then I have, so 3, 5 is going to be like right up in here, and then I'm going to have 4, 8. You see how this is on the same line? We don't want that on the same exact line. It cannot repeat. But if I was to graph 2, 9, I'm just going to be graphing 2, 9, 2, 9, and then 3, 2, 3, 2. Those are the same points. So I'm cool. That's okay. So you just have to be mindful if you're putting it on the graph, is it going to be able to pass the vertical line test, okay? Oh, Jerry, I cannot help you with that. I do apologize. I wish I could, but that's not my expertise. That's not my expertise. So any more questions about determining if a set of ordered pairs is a function or not? Hey, 2000 vibes, how are you? No questions? Okay, so let us talk about, let me see if y'all can grab this other one. So what makes a set of relations or ordered pairs? So the bottom one actually was a function because the point that was repeating, so I had 2, 9, and I had 2, 9, and then I had 3, 2, and I had 3, 2. So if I was to graph this, and I was to graph 2, 9, and then 2, 9, I would just be graphing the same exact point. Okay, I'm graphing the same exact point. So this is not, my input has the same output, and I'm cool with that. As long as this point is repeating with the same Y, that's cool. It just can't repeat with a different Y. Hey Felicia, welcome in. How you doing? Does that make sense, Cam? Welcome in, Felicia. Right, the Y can't be different. Right. Can't have a different Y. And on that top set, 4 repeated, but it was with 6, and then it was with 8. So this was a different Y. My X value had 2 Y's, and that's not cool. We can't have it. We can't have it. We can't have it. So my function knowledge does not go that far. These are basic functions, so not that advanced. I'm just touching on a little bit of it, honey, because if I could, I definitely would. Yes, I would. Yes, I would. So we know that domain is what value? Let's talk about domain and range for a little bit. Domain of a function and then the range of a function. Domain is going to be all of your what values? What does domain represent? X or Y. Hey, Sophie. Your inputs. Very good. So X, which is my input, which means your range is going to be what? Very good, Abel. Excellent. Good job. Vision. Your Y, and we also call that what? Hey, Jackie. Output. Perfect. Good job. Very good. Very good. Y'all so smart. Hey, hey. Independent and dependent. You said you don't like domain and range? Why? Don't be like that. Right, vision, f of x, so that's called function notation. So I'm just touching on a little bit of this because we need to remember that our domain is going to be all of our x values. And remember, this is every x value the function represents, okay? Every x value that the function has. So we have to remember that because it could go all the way up to positive infinity, or it could go all the way down to really, vision? It goes all the way down to negative infinity. Right. Yep. So we have to be knowledgeable too about if can we use a bracket, can we use a parentheses, things like that when we're writing domain and range. So Lex, yes, you can only put a parentheses around an infinity sign because it is not going to be included in the solution set. So that's definitely the right way to write it. Very good. Very good, Lex. Very good. Okay, so now let's look at graphs and determine if they are functions, yes or no. So I'm going to draw 4 graphs up here, and you're going to tell me, are they functions, yes or no? All right, so 1, 2, 3, and 4. Would these be a function, yes or no? I got a yes, no, no, no. Yes, no, yes, no. Yes, no, yes, no. Hey, Jackie, yes, 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 no. Yes, 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 no. You love functions? Oh, wow, good. Somebody said they want to be invited. 1 is the only function. Yes, no, yes, no. Cam, yes, no, yes, no. 1 and 2 are functions. 4 is a no. 2 of them would definitely be popping. 4 is the only one that's not a function. It has to pass both of the tests, 1 and 3. More than once. Very good. I like factoring better than I like functions. Very good. Yes, 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 no. Okay, so this one I drew a little crazy. I wasn't sure if y'all was going to be able to see it or not. So this one passed the vertical line test. This one passed. Now, if unless this is at a slant, it wouldn't pass it. This right here is skeptical. So the way I was trying to draw it was that it would like go like that, so it wouldn't be. But y'all get the point. You had failed the quiz. Oh no. Hey, Shabrisa. This one is a function. That one's cool, but this one is definitely not a function. So no, yes, yes, and this one is depends on how this graph is going. I was trying to draw it to the side, but y'all get the y'all get it. I just put up, hey Vex, I just put up a video on systems of equations. I just posted it. How about circles? So somebody asked, let's put a circle right here. That's easier. Let's put a circle right here. If I put a graph of a circle, would that be a yes or no? Shaprisa, how are you doing? Yeah, number two, Joseph, it was. It was. Yep, circles are not a function. Nope, very good. Doesn't pass the straight line test. Very good. X squared, x to the power of 3. Is it a function? You know what? I'm not gonna lie to you, Lex. I don't even know. I know x cubed. I don't know what I have to see what the graph look like. Hey, Sophia. You welcome. Don't get discouraged, Jared. Don't get discouraged. It's okay. All right. So we know it has to pass the vertical line test. Of course, your graphs will be drawn a lot better than that because my drawing is not orderbomb.com. But for sure will definitely be a lot better. See, because I was trying to draw this graph right here that said it was a function. But then they got one down here on the corner. You see this one right here, though? That said not a function. The struggle. The struggle. The struggle. All right. Let's do this graph right here. Yeah, we're going to talk about domain and range as well. So let's say, for instance, I'm given this graph right here. Do you know how to do domain and range from a set of points? That's super easy to do domain and range from a set of points, right? Let's say we have a graph that's drawn like this. And this is my vertex, and this is at -1, -2, -3. Okay, so we're going to say that this is -3 and 1, 2, 3. We're going to say -3 and 3. My bad. 3, -3. There we go. 3, -3. So the domain and the range. So domain and the range. You need to determine all of the x values that are included in this graph and all of the y values that are included in this graph. Okay? I'm sorry. Hey, Jazz. Hey. I just saw you. Hey, Jazz. So let's look at what's going on. This is your x-axis and this is your y-axis. Your y is your range. Your x is your domain. Looking at this graph, this is important because this tells me where my graph no longer descends. It does not go past this point here at -3 on the y-axis. But looking at this graph, it's going to go up and continue to go up forever and ever. So for my domain, I'm going to say it starts at -3 and it goes all the way up to positive infinity if you want to use interval notation, okay? And they also talk about if it's a closed circle or an open circle. You could say that the range is also greater than or equal to all real numbers greater than or equal to -3. Now for your domain, which is your x that's going horizontally, it's just going to be all real numbers. That's simple. That's it. I'm sorry, V. I apologize. I'm sorry that we missed each other. Hey, Lee. Yes, Cam, all real numbers. Somebody said they had wanted to join and talk about domain and range, but you are the love of my life. Let me see. The domain is positive, yeah. Negative infinity to positive infinity for the domain. Yep. Girl, I know. This is supposed to be scooted up. It looked like it's at the -2. Hold on, let me do that for y'all right there. That's why I put the point right here. That's -3. That's 3, -3. Yep, the domain is all groups. I don't know. I'm double page homework every day. I don't know about the groups. Sophia, why is it all real numbers? Are you talking about why is the domain all real numbers? Thank you, Hadley. So think about this. If I was going to make a T-chart of all of the values of X and Y, right? If I'm looking at how this graph is going, how is it going to continue to go forever and ever and ever? It's going to keep opening up wider and wider and wider. It's going to stretch horizontally forever and ever and ever. So every single point on the x-axis is going to be included, okay? Every single point on the x-axis is going to be included. So that's why. But it no longer goes down on the y-axis. It stops right here. It's like, boop. No. No. You can't go down no more. You got to stop at -3 and you're going to go up, okay? You can't go further than this. So that's why the range is -3 all the way up to positive infinity. And the domain is going to be all real numbers because it's going to include every single number on the x-axis. Okay, if there's an asymptote, then that's different. I don't go that far up. I just do beginning algebra right at the beginning of functions, so I can't help you with that. Then you got to do some more stuff with it. You know what I'm saying? This is my level right here. Baby, let me stay in my lane because I don't want to confuse nobody. Do you hear me? I don't want to confuse nobody. Lee, how's your weekend? Did you have to go to class today? Yeah, honey, I'm not here. I'm not here to mess nobody up. Just remember that anytime you're doing the domain or the range, you're trying to look where the graph starts or where it stops. So for instance, let's say we're doing a graph that looks like this. And we back here at -4, 0, right? So now this is my X, this is my Y. My domain is going to be every X value. My range is going to be every Y. Hey, Imani. They do some of this in algebra too, I think, but I'm not sure. It's not pre-cal though. No. Hey Tori, yeah, I'll put this one on my YouTube. It does have some, I have a couple, I think I have one function video on my YouTube, but I'll post this on my YouTube. I'll post it when I get off tonight. I'll do better. I haven't been posting, well, I did put up a lot, yeah, but I'll put it on my, yes, hey Nicole, You're so welcome. Joseph said that he will help you with any more like pre-cal. Do you do pre-cal, Joseph? Let me pin your comment. Joseph must be Joseph said he gonna help y'all out. Domain X greater than or equal to -4. Yes, Haley, very good. Very good. Hey, I am as well. Hello, Amari. Is that no, I am I don't know. -4? Yes, -4. So your domain stops at -4. So it's going to be -4 to positive infinity. Perfect. Or all real numbers that are greater than or equal to -4. Now for your range, just think about the range starts here and does it hit everything on the y-axis? Yes. So this is just going to be all real numbers. Your domain, your range is different. You're welcome, Haley. MIT grad. Oh, K through 4, really? That's cool. How exciting. How fun. That's neat. How cool. Congrats to you. Oh my goodness. goodness, I don't teach algebra 2, but Joseph said that he can help you, I think. Congratulations. Right, he said it's not a function, but in my book it says it's a function, so I don't. We're doing the domain and the range. Ooh, 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 ooh. Oh yeah, it wouldn't be a function. Well, we're just doing the domain and range right now, though. I don't know sign domain. You're welcome. A long time ago. Right, and we're talking about if things are functions and not functions. That's what we're talking about. Functions and not functions. I just do beginning algebra. You said, what's the difference between having a negative infinity on the x? Oh, because the negative infinity on the x would be, hold on, let me see. You mean like if it was, oh, it would stop. So for instance, like let's say it's like this. Is that what you mean? And like say this was 2, right? So this is at 2, right? So this would be 0, 2. So your range would then be negative infinity up to positive 2. That's what that would look like. Right. Tomorrow at, well, I don't know if I'm going to go live tomorrow, but it's usually Monday through Thursday about 8 o'clock. Yeah, this is a parabola. Mm-hmm. You're welcome, Maddie. Negative infinity 2. Yep. So not for the range. It's a bracket because it's a point. Right. So look, the range is your y values. Your range, it stops. It doesn't go any higher than positive 2, so it stops. But if you wanted to do like on the x, then it would be going this way, right? And you had to find the domain going this way. Well, let's say that this was 6, 0. Then this would be negative infinity up to 6, but it would be for the domain. So it just depends on what part it's on. So Gracia, if it was the, let me see, domain is negative to negative. Oh, okay, Lex. So no, because you're coming from negative infinity. So that's what you're asking me. So you're coming from negative infinity to positive 2. So think about this is like your negative side and this is your positive side. So you got to understand on the number line that your negatives is over here and your positives is over here. So it's the same thing as if you're looking at a graph. You're going from negative infinity to 2 and then you stop. You see what I'm saying? So it has to, all that works together. How do you know if it's infinity? It keeps going. Like he said, anytime you have a graph that has arrows on it, it's going to continue going in that direction forever and ever and ever and ever and ever. So that's why it goes to negative infinity. So that's what happens. Yeah, if it's positive, right. You see how we wrote it the time before that? When it was positive, we flipped it the other way. So let's look at a positive one real quick. So if it's positive, for instance, if I'm going to positive infinity, so let's say I'm down here and I'm going up, this way, right? And this is -0, -1, okay? And I see that my graph is stopping here at -1. So now it would be -1 to positive infinity. And it would be on that side. You said I'm patient? Oh, I have to be. Right, the one on the left doesn't pass the vertical line test. We're just doing it for domain and range. So for instance, if it was like this, that will work, okay? Just giving them examples of how to notice the domain and the range, because this could be a function. So it could be drawn like this. So let me not confuse y'all. If it was drawn like this, then my domain and my range would both be written differently. Only when it has the, you know what? I don't know how they do it. I know when it has arrows, though, that's what you're supposed to do. Thank you for sharing the live. I just picked the point. So you do a bracket when the number is included. You never put a bracket. You never put a bracket around the infinity symbol. So let's say, for instance, that you are graphing this and it is an open circle, meaning that this 0.60 is not included in the solution set. Then you would write it like this. Let's pay attention. This point says the graph no longer extends past 6 for my domain. It does not either go down for my range. So this would be negative infinity up to 6. But I'm not going to put a bracket around it because this number is not included in the solution set because I'm using an open circle. For my range, I see that this does not go down into my negative numbers. So then my graph starts at 0 and it's going to go up now, right? It's going to go up to positive infinity, but I'm not going to put a bracket around either one of those because it's not included in the solution. So it all depends on how, you know, if it's a closed circle, if it's an open circle. Hey, Aaliyah, all of that makes a difference. All of that makes a difference. You're welcome. Woo! Okay. In this problem, well, your range is going to be all of your y values, okay? So answer me this. And I'm going to use, let's draw a new graph. Let's go from the other direction. And I'm going to use a closed circle this time, going this way, okay? I'm going to say that this point is -2, okay? This point is -2, 0. So my graph is here at -2, 0. Please tell me the values that will be, oh, Houston, oh my goodness. Hey, M. Oh, y'all are so welcome. Y'all are a blessing for hanging out with me. Well, you better be the best dermatologist ever in life. So my domain is -2. Very good. My range is 0. Vivian says -2. Very good. So my domain is included. It will begin at -2 and it will go to positive infinity. But my range, does it extend down into the negative? Do I have any numbers that are going to be included on my negative? No. No. Where does it start at? It starts at what number does the range begin at? Thank you, Joseph. It starts at 0. And it goes to where? Does it go to positive infinity, negative infinity? Is it only at 0? How does it work? So it starts at 0 and it extends all the way. It goes to infinity. And we're not going to use, so that would be your range in your domain. Very good, everybody. Very good. Oh, Life, you did? Well, you helping us out? Can you do the one that is a square shape? You're welcome, Vivian. Does that make, okay, you're better? Okay, good. A square shape, Sophia? I don't know a square shape. Well, what you mean a square shape? I don't have it. I don't think I have. Joanne, why don't you get it? So the brackets are telling me that that point is included in the answer. If this was an open circle, then I wouldn't put a bracket. You only put brackets around numbers that are included. So brackets are numbers included. So those are closed circle. An open circle gives you parentheses because those are not included in the answer. And you never put, those are always parentheses. You never put brackets around infinity symbols. If it's an open circle, and then this is for a closed circle. So you put brackets around closed circle points, parentheses around open circle points, and you always put parentheses around positive and negative numbers. I mean, positive and negative infinity. Oh, congratulations, Mimi. Good job. I've never seen a square. Yes, M. We did the vertical line test earlier today. I've never seen a square shape. Love you too. Yep, I taught it. When I get off of live, I'm gonna post this on the YouTube, okay? Differential equations. Yes, M. I know those. M, I remember you. How are you doing? I can do a V-shaped one. The square-shaped one, I wouldn't even know how to tell you to write the domain on that one. Not sine and cosine. Factoring M, my other M. Go check. I have a video. I'm going to post it. I did factoring last week. I just did one. You have a test tomorrow? Go look at my YouTube. I have a couple videos on there about factoring polynomials. And I'll put up another one tonight. I'll put up another one tonight. Oh, thank you, M. You're so sweet. Good job. You made an 80. Cubic functions, I can't help you with that. I'll have you more confused than you need to be, okay? Composite functions, can't do that one either. Sorry, love y'all to life, though. Okay, somebody wants me to do a V-shaped function. Okay, sure. So I'll leave all that down there. And then this will be our last one. Lee, you still in here? Shaprisi, y'all in here? Do you post about inequalities? I do have a post about inequalities on my, I have one on there on my YouTube. I do. Linear inequalities with the graph in it. Yes, I have a teaching on there. I put it up a couple weeks ago. It shouldn't be too far down. So I do have one on there. So let's say that this is -1, -2, and then this is, we'll make this 1, 2, 3. So this point is going to be 3, -2. Around 8 o'clock. Oh, you're welcome, M. Watermelon. Yeah, go check it. I have linear inequalities on there. I think I may have 2 videos about linear inequalities on there. So these brackets mean that it's a closed circle and that the numbers that are here are included in my solution set. The open circle makes us use parentheses in the numbers, and we can never use brackets around infinities because we can never include them. It never reaches the value. Good job, Josh. Yep. Never reaches. You was lost. Oh, hey. Oh, I don't want to mess up your name. I think it's Sierra Akaria. Thank you. I'm glad. Hey, Nunu. All right, so you asked me to do a V-shaped function. Why are you confused? It's beginning algebra. So what about my range? What's happening with my range? So this point is 3, -2. This would be an absolute value graph. Yeah, they wanted me to draw a V-shaped function, so that's what I did. The domain is all real numbers. Yep. Domain is all real numbers. Very good. This was for my last graph, y'all. So my domain here would be all real numbers. And what about my range? So this would be from -infinity to +infinity if you wanted to use that. And then what would my range be? Oh yeah, that's from my last problem. The domain is all real numbers because the graph is going to hit every number on the x-axis. And then, very good, it starts at -2 and goes all the way up to +infinity. I have maybe one video on function. I'm going to post this tonight when I get off of here though, Sophia. I don't talk a lot about functions because I did beginning algebra when I taught, and so all we did was the vertical line test, domain and range, and I taught them how to substitute in values to find a function. That's all I did. Hey, no corona. I don't have any piecewise functions though. Somebody said I did, and I was like, I don't think I do. So yeah. And I can do like a couple word problems, but other than that, I did my hair today. It was supposed to be cute. But yeah, so that's really all I do with functions. I can substitute in values, but that's really it. That's really functions. That's all it is. That's all it really is. Nothing too serious. She said, child, I don't get it. Oh, because the range, does this graph extend past this point, Vivian? So the range is going to be your y values. Where does this graph begin? Think about it. Does your range come down here? Like, for instance, is this point included? If I put that point right there, is that a part of the range? Can I include that? Can I include that? Because this would mean that I would have to say like -4, but that's not included. Right. So then I can't say that my range is all real numbers because the graph does not come down past this -2. And we are telling or defining the range is saying these are all the values that this graph covers. Okay. The only values for y that this graph covers is all the way down to -2. Now, somebody just said, why isn't it all real numbers? Or, you're welcome. Somebody said, why isn't it +infinity to -infinity, I think, for the range, I think. And that's the same reason. So, -infinity would mean that the graph was going to go and extend to the negative values, and it doesn't extend to the negative values. Don't be embarrassed. A lot of people didn't pay attention. They didn't know that they would need it or want it or anything like that. So, you're welcome, life. No problem. Hey, Watermelon. So fast faves. You are not dumb. Y'all don't say that. Because you need math for everything you do. And people always say that, like, why are we going to use math? Why are we going to use math? The bed you slept in was made with math. The stairs you walk on, the house you built, that you lay your head down in, the car that you drive was made with math. So people, I said, I'm going to start telling people, when am I going to use math? You use it every day. The chair you sit in to make sure you don't fall and bust your tail on the floor, that was made with math. That's how they use math every day. The medicine that you take, the vitamins that you take to make sure you don't overdose, that's math. Everything is using math. The speed on your car to make sure you're not everything. You use it every day. You may not calculate it every day, but you use it every day. Somebody had to use math for you to use whatever you're using. So that's how that works. So that's why I say I'm going to start telling my students the soda pops that you drink, them energy drinks, to make sure you don't have too much energy. If you flip it on the back of the can and it say the percent daily value, that's math. You use it every day. Use it every day. All day, every day. Every day. Yes. Y'all think y'all don't use it. I do beginning algebra. That's all I do. Middle school, first couple years of high school, that's all I do. That's all I do. And matter of fact, it's almost time for me to get off of here, y'all. I'm going to put these videos up for y'all to watch on YouTube. The people that were asking for this, as soon as it's done downloading, I will put it up. There you go, Lee. She said the more, that's my mind. Hey, I was wondering if you were still in here. The more, your brain is definitely a muscle. The more you use it and build it up, the better it will be. Probably about 8:30 tomorrow. Usually that's what. Yes, pay attention in class. And if you're missing those foundationals, like the adding and subtracting, math is literally like a building block. That's it. It is. And if you're missing the foundation, I might encourage you to go back and get that foundation solid. Okay. My YouTube is my name. It's Sophelia B Math. It's on my page. If you go to my TikTok page, and I got a little YouTube button you can click on. But if you have like questions, like I said, I don't go very extensive in math, but I can definitely help you with your fundamentals. I can get you solid on that foundation, though. I can do that. You got this, Paige. You got this. What grade are you in? Hey, Kareem. I'm so glad y'all are here. I do answer DMs, so DM me. If you have a question, yeah, I do. I answer. I ain't that busy. I'm not up there like that. I answer my DMs. You talking to me, right? Kareem? Carry me? No, I answer my DMs. People email me all the time and DM me. All the time. You're welcome. Yep, hit me up. Hit me up. Hit me up. Hit me up. Oh, I don't like nothing to do with the devil. But love y'all to life. Lee, you good? Shaprisa was on here earlier. I'm locking in for Algebra 2. I keep doing little mistakes to bring, them. Are you in 8th grade? Oh my goodness, y'all so young. So yeah, those little bitty mistakes will mess up your whole problem. Like you said, once you lock in and you really, focus and remember those little tidbits, you good. You fine. If that's all you forgetting, you good. You gonna be just fine. Just fine. Y'all are amazing for even being on here. The fact that you on here on TikTok at Math Club, we call this Math Club. So welcome to Math Club. Come back and see us. We lit over here on the Math Club, okay? It says a lot about you. Okay, so the simple fact that you're here at 8:54 at night talking about math, you the bomb. Okay? Oh, good.